Good morning, everyone. Myself, Semashal, being a pin number lateral maintain. Today, now I am pursuing the BTech second year in the branch of ECE. Today, I tell the topic about random variables. Let us see. First of all, contents of this PPT is introduction of the random variables, importance of the random variables, types of random variables, main variance and standard deviation of these functions, applications of random variables, final conclusion of this PPT with examples also. First of all, introduction of the random variable. Definition of a random variable is a random variable is a variable. It is denoted by like x variable. A random variable is a variable whose possible values are outcomes of a they are outcomes of the random phenomena. They are essential because they allow to us model real world uncertainty in a mathematical form. Importance of the random variable. Random variables are central to the probability theory and statistics. They help model uncertainty outcomes in experiments, finance, engineering, and natural science also. In data science, they form basic predictive models. Random variables are two types. One, discrete random variables, another one is continuous random variables. First of all, discuss about the discrete random variables. Discrete means countable values are countable values in the form of discrete, this like 1 to 3 are point values, etc. These variables can take only specific countable values. For example, the number of effective products in a batch. For example, in a batch, a complete batch is 30 products. You can calculate the how many products are defected because to verify and all the products. So they are often used in counting problem and quality control. The examples of discrete random variables. Rolling a die. Outcomes. How many outcomes? How many sides of the die? 6 dice. Six sides. They come 1 to 6. Anyone also. Another one. Number of students present in a class. You can calculate. You can calculate because of students. Number of students in a class is limited. Probability mass function. Shortcutly PMF specifies the probability that discrete random variable is exactly equal to some value because it only applicable for discrete value because discrete values are equal to probability equal to some value because they must because they satisfy two conditions. First condition is probability lies between 0 and 1. Don't negative probability. Another condition is the sum of probabilities for all possible random variable is 1. Another type of random variable is continuous random variable. These continuous random variable take infinitely many values within a time interval. They are used when the measuring attributes like time, temperature, distance, weight, moisture, etc. For example, the exact height of a student or the time taken to finish task. For example, in a class, there are 40 members of students. The exact height is 5.5, 4.5, 5.25, 5.45, etc. For any finished task in a running competition, they only calculate minutes. They calculate milliseconds also because they're taking continuous time. Now I discuss about the next topic is probability density function. This is also called as small PDF. In this probability density function, describe the probability distribution of the continuous random variable. Unlike PMF, probability are calculated as area under the curve. The total area under the curve is equal to 1. Another one is cumulative distribution frequency. These are also called a probability distribution function. Probability distribution function gives the probability of the random variable will take a value less than or equal to x, means a random variable. It is useful for calculating range of probabilities and understanding the overall distribution behavior. Expectation means mean. How to calculate mean or average value? For average value, how to calculate average? Sum of all outcomes by 2. Average sum of total outcomes by 2. దేనైనా by 2 చేస్తే average వస్తుంది. For example, mean expectation. Mean means expectation. The expectation is a long run average value of the repetition through the experiment in present to provide measure of the central tendency. This means if you're tossing a coin once times, either a head or bucket, head or tail. But tossing a coin repeated times, how many times to get head or how many times to get toss? It calculates the mean. Mean also calculate two, like discrete and continuous. For discrete, mean formula is expectation of x is equal to summation of x into probability of x. I think probability x means a random variable, random function. For continuous random variable, the mean calculated by the expectation of x is equal to integration of x into fx of x into dx, integration variable. Another is variation and standard deviation. Variation measures how much the value of random variable deviates from mean. Standard deviation is the square root of variance and represented present in some units and variables. Formula for variance of x is equal to expectation of x minus mu whole square. You're also told me. And standard deviation, root of variance of x. Common distributions for discrete random variables. There are three types. One, Bernoulli's distribution, binomial distribution, Poisson distribution. For example, Bernoulli distribution model is a single experiment with success or failure outcomes. Where tossing a time, single experiment with success by failure outcomes. Next one, binomial distribution model is the number of successes in an independent Bernoulli trials. For Poisson distribution model, the number of events is fixed in a fixed interval of time space. For example, you can tossing a coin 1,000 times. How many times to getting head? Is possible to predict the probability of getting head? No, because of our number of times to repeating problem. It can be calculated by Poisson distribution also. Continuous random distributions. There are also three types. One, normal distribution, exponential distribution, and uniform distribution. Normal distribution is a bell-shaped, widely used in natural and social science. Another one is the exponential distribution model is time between events in a Poisson process. Another one is uniform distribution. All outcomes in an interval are likely equal to 1. Applications of random variables are applied in real life also. Quality control for manufacturing defects. For example, in the industry, they are manufacturing some product in base level and reach the last level is output level. They consider how many input are taken, how many quality of the products are product manufactured. They're calculated how many products are defected and how many products are being good. They also estimate the probability of the manufacturing. They can reduce the errors. Another finance to model stock returns. In finance, companies and stock market to calculate the market ups and downs. And another application is AI and ML of probabilistic models. Another one, risk analysis and incidence calculations, and engineering reliable testings. Finally, conclusions of the random variable is random variable provide a framework for analyzing uncertainty. They connect real world randomness to mathematically probability theory, understanding the themes that crucial for statistic data and analytic decision for making uncertainty. Thank you for this opportunity to giving for me.